Hey everyone, welcome to CoddingAdda. Today we will discuss on Goroutine and channel. We have discussed on Goroutine and channel just for an overview in our previous lecture. Today we will discuss more on detail about channel and Goroutine. We will try to solve a real use case today. So without further delay, let's get started. What we are trying to do, we are trying to develop one site checker application. Some certain websites are up or not. We will check Facebook, Google, and Stack Overflow in our example. So we'll check whether Facebook is up or not, then Google, then Stack Overflow. This is our use case. So first we will try whether Facebook is up or not. Then we will go to Google. Then we will go to Stack Overflow. From this diagram, you are thinking that this program will be synchronous. Yes, the traditional way will be synchronous. Now we'll go to our program. We have one slice of string, that is links for Facebook, Google, and Stack Overflow. Now, just simply we are looping through this links. We have used the range keyword for this. Now we are calling our function checkLink. This function is responsible for checking whether the particular link is up or not. You can see here we are doing one by one. First Facebook, then we'll go back with the result, then we'll go to for the second link, then we'll go to second link, then we'll go to third link. So we'll do for all the links the same job. Let me explain the logic how we are checking the particular link is up or not, although this is secondary in this example. Just we are calling the link http.get. We are using HTTP package here that belong to net package. It will give us resultant error. We are not bothering here with the result. That's why we are only taking error in this error variable. If error is not equals to nil, that means there is something happened, the error happened. That means the link is looks like down. So we have in remarks looks like %s is down, percentage is link. Looks like link is down. Now we are printing fmt.println. We are printing with time.now.string. So we are printing this string with timestamp. Then we are returning. If this is down and if error is nil, that means we are good to go. We are printing looks like link is up, and then we are printing this statement, the string with the timestamp. So this will be a synchronous program. So if we need to check thousand of websites, maybe more than that, because we want to develop a site checker application, that will be lots of links to check whether those are up or not. It will be very slow. This is not efficient at all. Nobody will use our site checker application. So we have to think now how we can improve our this program to a very efficient program. We have to do something asynchronous. Now you got it, right? Yes. So what we can do? We can obviously use coroutine. You know till now that coroutine executes asynchronous. Let's change this program with coroutine. Now to make this function or to execute this function as coroutine, just we are calling with go. So we know from our previous lecture that we have to just call the same function with go here. We've done this. Let me execute. So nothing is printing. Now what will happen if we just call this function with go qr, then this will become go routine. But somewhere here we have to wait, right? Otherwise the main program will be completed its execution, then also this go routine will be running. So we will not get any output. We have to wait here until all the go routines done its job. So how we will do that? We'll move to next page where we have modified this program. We have added this code to wait here until all the routines are done. So here what we are doing, we are waiting and we are adding one more functionality to our site checker application because we will not just do whether Facebook is up or not for one time. We will check maybe after 5 minutes or maybe 10 minutes, whatever it is, we'll hit that link of Facebook and we'll try to understand that whether Facebook is up or not. We'll do same thing for all the links we have. We'll do in a frequent manner. We'll check. So that's why what we are doing, we are looking for one channel. And here we have taken one channel. So we know channel is the medium who communicates between the routines, right? So what we have done, we have taken one channel of string. So this channel will contain the value or this channel will contain the data of type string. Okay, so now we pass this ch channel here. In our previous example, we don't have this channel at all. Now we have taken one channel and we are passing this channel in our coroutine. Then this coroutine sending the message in the channel. So link, this is a string, this link that we are passing when we are calling this coroutine. Then we are sending this link in the channel. Okay, when it's done, maybe for the success scenario or the error scenario. This is the error scenario. In case of error scenario, we are sending the link back to the channel. Same we are doing for success scenario and we are printing the link is down or up. Okay, so this line is blocking until we get a value from the channel because we know channel is a blocking operation. Here, our main program, main routine will wait. until it's get any value in this channel. So we launched three go routines for this link. Let me go to this example. So from main go routine, we launched three go routine. One for Facebook, other for Google, and other for Stack Overflow. Now these three are executing asynchronously. We passed one channel as a reference in this go routine. So main and this go routine will communicate via the same channel. So main program will wait here, okay, after launching all this go routine. And then as soon as it gets one value in the channel, maybe for any of the three go routine, we don't know which one will be. For that go routine, which will take less time to execute, and that go routine will gives one value in the channel. Then for that, it will enter inside the for loop. Then what it is doing? It is calling one function, invoking one function. This is kind of immediately invoke function expression. The similar concept like in JavaScript. This function is calling. So it's taking the same link because in the CH we are sending the link. So here we will get that link and we are using this link, we are passing and this function, we are declaring and calling this function here. This is called immediately invoke function expression. This is the function body. This is the function body. Then we are calling this function with the link and we have used go period also before the function period. That means we are executing this function as a go routine. So we are waiting for 5000 milliseconds because we will do a frequent check, not immediately. We'll wait for some time, then we'll again check the same link is up or not. Then we are calling the check link function again with the link and check. This way, we will do infinite time for these three links, whether this particular link is up or not. So for the first link, it will do. Then again, it will wait here. The main program will not exit because channel is blocking operation and we have yet not received the link from other go routine. So it will immediately wait here for other go routine to complete its job. So here we will wait for infinite time. So this way we have built a real site checker program where we'll do a frequent check whether a particular link is up or not. So here we have learned a new concept also, that is immediately invoke function expression. So we are just declaring, then immediately we are calling the function as a routine here. So this is an anonymous function. It doesn't have any name. I think you have understood the concept. So this is our diagram, that is we have implemented. When program is launching the go routines, then it's waiting to get the value from the channel. After getting the value, after getting the link, again it's calling the same site checker function. Then this way it's waiting for infinite time at the end of main to become a real site checker program. I guess you have enjoyed this lecture. Thank you. We'll meet in the next lecture. Bye.